Welcome everyone. I'm excited to be here. Thank you for joining me today. So imagine that you are hosting a party and you're not sure how many people or how many guests will show up. You could reserve a fixed number of tables, but what if more people come than expected? Or what if just half people show up? So you either be headache fighting some for more space for more people, or stuck with empty table and waiting resources that you reserve for. So that is a lot like traditional Kubernetes capacity scaling is working today. You allocate capacity upfront, but the reality is things always change. Hi, my name is Chakkree, a solution architect from AWS. So I'm here to walk you through some capability of Carpenter and demo as well. So let's dive in. So now, what if the table that we mentioned at your party can automatically be expanded or changed based on how many guests arrive? No waste, no scrambling, and yeah, so always the right side. That is what exactly how Carpenter does for our cluster. So let's see some of the challenges that we have today in the Kubernetes and also Amazon EKS with cluster also Autoscaler. So here you have like deployment, and also you have the existing node already that run 2 pods, right? So you have 2 vCPU here for M5 large, and then the scaling up mechanism kicks in, maybe come from K8s or HPA, depending on the cluster. And we have 1, 2, 3, 4, 5, 6, 7 pods in pending state. So some of the pods will be scheduled on the existing node, and some of the pods will need additional capacity. So that's why we need cluster autoscaler, and cluster autoscaler works with autoscaling group. So here we can have a new instance here, which are M5 large for 2 instances. Some of the pending pod will go to the second one, and just one more pod will go to the third instance here. We can spot 2 things here for the challenge. The first thing is that it take longer time to spin up a new instance for schedule the pods, because cluster autoscaler need to work with autoscaling group, and then autoscaling group need to work with EC2 API. So there are multiple steps to spin up a new instance here. This is a problem number 1. And the problem number 2, if you can notify or observe that on the third instance, we have only 1 pod running, and we still have 1.5 CPU left. This one is underutilized. So we would like to try to find the right size of the node that fit the pods that we need to run. So that is the thing that we need to be solved. And coming into the third challenge that we have for the existing cluster with cluster autoscaler. So if you can see here, this is the deployment that we already deploy, and is based on the CPU request and CPU consumption. But how about when we have a new deployment that need a GPU workload or another type of instance? So now, this pod or this deployment cannot be scheduled because this capacity that we have doesn't support the GPU workload. So the things here is that for platform team, they need to create a new new node group. So the first one is for the compute node group, and another one is for GPU node group. So here, after that, the autoscaling can spin a new type of instance to support a deployment which would like to use the GPU. Now it's done. So we have 3 main challenges here, and we would like to see what kind of things that Carpenter can make it like more efficient or better. Let's see. So this is the existing one. When we have pending pod and we don't have enough capacity, cluster autoscaler kicks in, and then cluster autoscaler we work with autoscaling group. After that, autoscaling group will spin up a EC2 instance by calling the API to EC2 fleet. So multiple steps, just like I mentioned. But for Carpenter, so we don't need these 2 components anymore, and we don't need to go through the autoscaling group. Also, the node group concept will be gone. And we can bypass that by replace those two modules by Karpenter. And Karpenter can spin up the EC2 on our behalf. The instance that Karpenter spin up, it will be always the cheapest one, depending on the configuration. And also it will be always the right size for the pending pods. So let's see how it works. So here we have that running 9 pods of our deployment. The type of the instance here is C5 to X-large. And now we don't run cluster autoscaler and autoscaling group in our cluster anymore. We have K8s and also Karpenter installed. How about now we have the GPU workload? So now if we configure the Karpenter configuration correctly, so Karpenter can spin up a new workload which support the GPU workload automatically. And you don't need to do anything. You just configure in the node pool configuration, which we will go through in the couple of slides. So here, the new workload can just be scheduled in the new instance that coming up from Karpenter. I think this one is the third problem, right? But we can see the first one is already solved because we bypass auto scaling group. But this one is the third one, but we will revisit the second one later. So here is the configuration that you can do that I mentioned, that you can configure the node pool for Karpenter, how it will behave in your cluster. You can have a multiple node pool as well, but depending on the situation. So here we have the configuration that we can choose from the different types of instance. So you can use a wildcard here, like you can use only C or C5 or C6 or something like that. You can use M, you can use R, and you can also specify the size like nano, micro, small, large, X large, something like that. So depending on the use case, you can specify wildcard or a specific one. And how about the availability zone? You can also specify here that you allow Karpenter to spin up a node inside that particular availability zone. Or you can choose either architecture for the CPU by using x86 or 64 here, or you can also use the AMD 64, sorry. And you can also use ARM 64, which is Graviton on AWS. So Graviton provide better price performance compared to x86. So if your application is already tested that it supports ARM, so you can use ARM here as well. And the final one is the capacity type. You can either go with on-demand or you can utilize spot as well. If you specify both of them, it will try to prioritize the spot. And then you have the limit here. The limit specifies that this node pool can spin up maximum 100 CPU only. And when it exceeds 100 CPU, we cannot spin up a new node anymore. Okay, for the node pool, you can have a single one for one cluster. So this one is quite simple, maybe in the test environment or dev environment, or you have a unified node pool configuration that support all the workload in this cluster. So it's quite simple for the single one, single node pool. But for a multiple one, you can have maybe multiple team that need the different requirements for the node configuration, or you have the expensive hardware. Some of the team need the GPU workload, or like you have different image or AMI in your workload. Like one workload use a battle rocket and one workload just use EKS optimized or something like that. So you can have multiple one to support different kinds of workload. And you can also put the weight on the node pool as well. You will try to prioritize the higher weight node pool first, and then when it run out, when it reach the limit, maybe the first one can spin up only like 10 CPU, depending on the maybe saving plan or reserve instance that you bought from AWS. And then other than that, maybe utilize spot or on demand. So you can use weighted node pool as well. Okay, so here is the challenge number 2, that we have some of the nodes that are in underutilized status. So you can notice here on the 2 instance on the right side, we have only one pod running, and it's the M5. They are M5 X large, which is quite big compared to the workload is running then inside these 2 workloads. So in Karpenter configuration, you can also specify that when will you do the consolidation. Consolidation means that it will try to move the workload together, try to bin packet to save the cost for you. And you can also specify the time that it will do the disruption or move the workload for you. So here I specified as 0 seconds. So it will try to do consolidation every time that it sees that the node is underutilized. It's quite aggressive here, but for demo purpose, I just would like to spin it up quite fast or do the consolidation quite fast. You can also specify like 1 hour or 24 hours or 1 day, 2 days, depending on the use case. So now it can group together for those 2 pods to inside the exiting capacity. And this is the first case, and here is the second one. So the same, you have here M5 X large, and two of the pods are running separately. And when you enable the consolidation, it will try to find a node that fit these 2 pods and spin that up and try to drain these 2 pods to a new instance to save you some cost. Let's see. Here it will group together those 2 pods, and then it will move to the new instance, which is M5 large. So it will reduce the overall cost of the cluster. Yeah, you can see that we solved all of the 3 challenges that I presented back then. So how about some other features as well? Recently, we launched Karpenter version 1.0. So this feature also supported as well that you can do automatically upgraded by detecting drift of the Karpenter configuration. There is a custom resource, another custom resource. It's called EC2 node class. For here, you can specify the image that you would like to use, the security group, and also the availability zone as well. Yeah, under the spec, we specify that we would like to use the latest image that it comes out. So it means that if AWS update the EKS optimized AMI for the new version, Karpenter will try to upgrade every workload under Karpenter and upgrade to the new one, and also try to drain the pods for us. So this can be done automatically, and it will force every time that we have a new AMI for AMI that you are using. So the new version comes and then it will be automatically upgrade. But sometimes you can also do something like this. You can pin the version that you would like to use this one. When the updates come out, it will not be automatically updated. And then you can change the value inside the 2 node class later when you would like to do the upgrade. And this one can be specified with the custom AMI that you have as well. So quite flexible for this one. So now coming into the demo that I prepared for you. So let's see here. What do we have? Let's see. So for the nodes, we have 2 nodes here. The type is a 3 large, 2 nodes, and I think so. Let's see the workload. What kind of workload that we have? Okay, we have coordinates in kube system. We have Karpenter. This is the controller. So I spin up for 2 pods for under the deployment because I would like to provide the resiliency. And then I have my workload here. The name is inflate and the replica is 0 now. Let's see what kind of configuration that I have in that inflate deployment. So it's quite basic. The name is inflate and the namespace is inflate, and the CPU request here is 1 CPU. I didn't specify the memory requirement, and it will just pull down from the public ECR repository. And it did nothing, it just reserved the CPU. That's all, I think, for now. And how about the node pool configuration that we went through? So what kind of thing that I configure? Let's see. Okay, yeah, we have only one node pool here. The name is the default. You can have multiple, just like I mentioned. And the version is version 1, of course, because we launch as a stable version. Consolidation policy now is when it's empty, and we change later. And the consolidation time is 5 seconds. The limit here, this node pool can spin up only 10 CPU only. After that, it cannot spin up a new instance. Architecture is x86. The capacity type is on demand only. And the instant type here, this node pool can spin up a C type, M type, and R type. So let's see what kind of things will happen when we scale up our workload. Yep. So we spin up 5 replica here, and so we have 5 pending pods now. So you can see it's detect quite fast. And we spin up a new one for us. It's C6A2X large. It's not ready yet because it takes some time for the node to be ready. But yeah, it's super fast to detect. And this one is faster than Autoscaling group and cluster Autoscaler. So it takes some time for that. So now is also spin up 2 pods. It is the kuproxy and also kubelet. Yeah, so all of them already scheduled, 5 pods, and it's the right side for this kind of pending pods. So let's see the logs to understand it further. This is the log from Carpenter. So here you request for 5 pods that we see in the pending pods, right? And then Carpenter will try to come up with the right size instance. So here we request for 5 CPU, the number of pods is 7 because it includes kubelet and kuproxy. So you try to search through the instance type that we specify in the node pool, like 45, 46, yeah, instance type. And it came up with C6A2X large in this availability zone with on-demand type. And this one support pods. This one is depending on the number of elastic network interface. Now it's already registered and ready to host the pods for you. Yeah, that is the log. How about now we scaled up to 20? So some of them can be scheduled in the existing node, and some of them will be scheduled in the new instance that's coming up here. So it comes up with C6A large, but we'll still have some pending pods there, 13, right? I think C6A large maybe can support like 1 or 2. Let's see. Now it's not ready yet. So we need to wait until it's ready to see what kind of pending pod that we have. Yeah, just schedule just 1 pod inside the new instance, and we still have 12 pods that is in pending state here. Yeah, you can see here as well. And so, can you guess why Karpenter don't spin up a new one? Because it reached the limit that we specified that this node pool can spin up only just like 10 CPU only, and now it reached the limit. So how about we increase that? Let's see. Yeah, we will increase that to 1000 from 10. Then hopefully it can spin up a new node to support 12 pending pods. So now it's quite fast, you can see. So now it's spin up a C6A4X large. Here the limit already changed, it's 1000. C6A4X large, and it will fit over the 12 pending pods here. Soon. So need to wait for kubelet and kuproxy here. Okay, yeah, it's there, and it's all the pods is running. I would like to add ARM as well, the Graviton one, to save some cost. And I also would like to add the Spot as well. For Spot, you need to make sure that your workload can tolerate for the risk disruption that we call back the Spot. Okay, let's check the configuration that we add the Spot. and also the ARM architecture as well is up there somewhere here. So you specify x86, which is AMD 64 and ARM 64. Yeah, Graviton one, and spots as well. I think something will comes up here when it finds a spot for us because it's cheaper. It's deleting this node, so it's try to drain some pods out. Already drained to the existing one, maybe the lower one, and coming up with the spot soon. Okay, let's wait a little bit and let's see. Okay, here. So we have C6G. G means Graviton, which is ARM. And from on demand, we changed to spot here is much cheaper, like up to 70% cheaper than the on demand. Just wait to it to be ready, and then it will try to drain the pots for us. It will cordon and also drain for us. Yeah. Okay, now it's working for spot and Graviton, which help us to save some cost of our cluster. Okay, and it will delete the old one here. How about we change the consolidation policy from when empty to when empty or underutilized? Let's see. And here, consolidation policy from when empty to when empty or underutilized under 5 seconds. As I say, you can specify like 1 hour or 24 hours do the consolidation if you don't want to have any disruption. Okay, I will try to reduce the number of the workload here so that we have some underutilized node. Here we have 5 pods and 20% of consumption for CPU. And it will try to come up with a new node and drain for us. To make sure that our cluster is like more utilized. Yep. Now we have it. This one is also underutilized. So you try to spin up a new one and then move all the pods for us. Yeah. Deleting the other one that don't need anymore. So this is how it works for consolidation and also some other things like architecture, spot, and also the type that we can select. How about now we would like to do 10 and toleration. So we specify that Carpenter will spin up a node with the 10. The key is, my name is Chakkree. Here, so the node that spin up by Carpenter will have this 10. So the deployment need to have the toleration for this one. I will try to increase the number here of the workload. Oh, unfortunately that it will fall into the node that we have already. Then it can be scheduled. So now we add some more. So some of the pods here will be in pending because the Carpenter cannot spin up a node for it. The deployment doesn't have a toleration for the 10 key Chakkree. So cannot spin up here. So now we would like to add the toleration into the deployment so that Carpenter can spin up a node for us. So let's see. Okay, just add the toleration here in our deployment. Let's check. Oh, it's just spin up a new one for us. You can see C6G is for large. So let's see in the deployment that we have the toleration that I just added. Okay. Here is the toleration. That's why Carpenter can spin up a new node for us and yeah, schedule our pods. Boop. Okay. Okay, that's all I think. I think the final one is about the AC spread. So Carpenter will respect anything that you configure in your deployment. So here I would like to spread my AC from each other. And you can see that a lot of things that happening. So you try to spin up a new node for supporting different AEC. So this one will ensure that your workload will have higher resiliency. So this one is the configuration that I specify in the deployment that I would like to use topology spread. That if it cannot satisfy, will not schedule. You can see that do not schedule there. You can schedule anywhere as well. But this one I would like to show that Carpenter will respect anything that we put in deployment. So we would like to check when it's done that we have multiple AC for our workload here. So you can okay, we're deleting one of them. Maybe just wait for it. So here we have AC1A, 1B, 1C. So let's see again because it's deleting. Yep, I think we have all of the AC here. A, B, C for our workload. Yeah, it would try to balance the AC for us. That's all I would like to show. A lot of things that you can explore by yourself. You can also read to the best practice that we have online. So for onboarding to Karpenter, so you can install Karpenter by using Hemshark. And one best practice here that do not run the Karpenter on the node that is managed by Karpenter. Otherwise, it will just delete the node that run Karpenter and stop working. You can run Karpenter on Fargate or different node group. And you can also migrate from cluster Autoscaler as well. The guide is there and you can explore. So let's sum up. Also, Carpenter is fast. It's quite simple, but it's quite powerful. It's cost effective because it will try to reduce the cost per U by consolidation. And also it's Kubernetes because it's open source. Now we support multiple cloud already. And yeah, I think it's awesome. Thank you so much.